.txt, and another input called link delay. And here's the output called selected households. Selected households. Actually, it's not selecting plans, but selecting households. But they are basically the same, because we can use plan and the household IDs to identify those plan IDs. So it's selecting some households. Now I'm using this percent time difference. I'm not using this V/C ratio. I just directly skipped to the third step. So I use percent time difference, 10%, and between 2 minutes to 45 minutes difference. And out of those plans that have time difference, I select only 50% of them. But the total percentage will not exceed 10%. Clear? So I then run this plan select. After this plan select, I have an output called selected households. And I put this selected households back to router's input folder. Then I can run this router partial. The router partial is very similar to router all. The only difference is here, it has a household list. So it will only do the routing for the selected households. That's the only difference. Another difference is, I think, two differences. Household list and link delay file. And this time, the router already knows the link delay information, which was generated by link sum. And then, after running this router partial, the result is called a partial plan. Now I'm going to move this partial plan to plan preparation _ merge to merge that with the plan file that was generated very early by router. The router all. And that's the end of the first iteration. So I call this first iteration .bat. And I have another batch file called following iterations.bat, because following iterations are a little bit different, but they are we can run it by a loop. So in the beginning, I already got a merged plan by plan preparation. Then I can move that to plan sum. Okay, I don't want to explain too much here. Let me explain this one. Router stabilization. In router stabilization, the first thing it does is to call the first iteration. Then it calls the following iteration. Then as you like, you can put many calls to the following iterations. So here I have 9 iterations. The first one is called first iteration. Then I have 8 following iterations. All you need to do is to run router stabilization.bat. Then here I will show you the result. I recommend you to run it in the batch command line mode, because in my computer it used to have a problem when I run it in the Explorer. I'm not sure what problem it is. So let me show you. CD trans. So in this command line mode, if you don't want to type so many characters, you can press tab. See, press tab, and you can do auto completion. Then we go to 2 dot something. Press tab. Let me run first iteration. And after the first iteration, our output is here. Is in plan preparation merge. We have a merged plan.txt. I couldn't show you today because ArcGIS is not running, but I can tell you, in the first time when we run router all the plans are, for example, going through this path, because this was the shortest path, and all the 4,000 trips are assigned to this path. But after one iteration, some trips will be rerouted, for example, going to this path. And And if you run this for more iterations, then router will find more paths.
You can try address one more time.
Is it work?
It's a floating license.
No. I don't think it's working. I don't know why. Things always happen. But that's the result, okay? You can try it at home. So you run it several times, and you use arcplan. I have a folder called arcplan. Then you copy the plan file, merge plan file into the input folder. Then you run arcplan. Then you will see the shape files that were created. So you see shape files here in the output folder. You can do it at home. Okay, now do you understand what router stabilization is? So basically it's running for router for all household once. Then it's selecting and rerouting. It's doing selecting and rerouting for part of the households every time and merge. Select some of them, reroute them, and merge them back to the original plan. So that's the first loop. In the second loop, which is called micro-simulator stabilization, things are very similar. The only difference is instead of using plan sum, we are using micro-simulator, which takes more time, but is supposed to be more accurate. So in the first stage, we are using plan sum, which is using VDF, volume delay functions. In the second stage, we use this micro-simulator to replace this plan sum. And in the second stage, we have another two choices in this plan select. Let me show you. So in router stabilization, we have the plan select tool. But in the second stage, we have another tool that can also select some plans, which is called problem select. So this tool can generate a list of households with some problem types. Because when you run micro simulator, you are running traffic on a more specific, more detailed network. And in that case, you may experience some problems like the connectivity problem, or any other problem. Then you can use the problem select tool to select some household for rerouting. And another tool, the third tool is called event sum. So this tool can generate a list of households with significant differences between the scheduled travel time and actual travel time. So we have more options for rerouting, but the basic idea is the same. I forgot to show this slide for router stabilization. This is a table of parameters that was suggested in the literature for router stabilization. So it suggests you to use V/C ratio for 3 iterations, from the second iteration to the fourth iteration. And you will use 2.0 as the select VC ratio. Then we use 1.5 as the list V/C ratio. Then we use 10% time difference as the criteria. So that's suggested. But in my version, I just directly start using this criteria, 10% time difference. So if you understand this one, it will be very easy to understand this one, right? So the basic idea of micro-simulator stabilization is to get a big plan file and use the link delay, which was generated by micro-simulator, to select partial or select some of households for rerouting. So it's very similar to this. Using this tool to select some households for rerouting and merge them back. Okay?
So what's the meaning of done?
Done?
Is the number of iteration you decide?
Yes, that's a good question. By the word done, we are meaning two things. The first thing is, using this tool, you can no longer select any plans. For example, if you run the plan select tool, and it tells you no household can be selected, according to your criterion, then it's done. Another possibility is you have already run it 10 times or 20 times, and you think it has already reached the maximum number of iterations. This is like concept of multi-run in vSync.
Question. So how do they merge? So one is the all household plans, the other is the partial household plans. What do they mean by merge?
So we have all household, then we have partial household. By merging them, we actually mean we put all the plans in the merge plan, in the partial plan, into the big plan files and replacing the original plans. So the rerouted plans will replace the part, corresponding part in the original plan file. So you can also understand it as replacing the original plans.
So you only merge 5%, the others stay put.
Yes. If you have 5% selected and 5% rerouted, and you merge it back, then 90% of the original plans will be the same, and 5% will be updated. Okay. So we notice that in this stage, we run router all once, and we run router partial a lot of times. And in this stage, we run router once, and then we run micro simulator several times, and we run router partial several times. And the third step is called user equilibrium. In this stage, we are going to reach the user equilibrium condition by a tool called plan compare. Let me introduce that. So we already know user equilibrium, what user equilibrium is. And transients uses an approximate